This is problem 8-89. Sketch the graphs and find the area of the intersection of the inequalities below. So our first one says y is greater than the absolute value of x plus 3, and then y is less than or equal to 5. So the first one, x plus 3, and that's in the absolute values. The plus 3 inside touching the x means it's been moved over from the origin to the left 3. Remember, it's kind of the opposite of that. So that's going to be kind of the start of our V shape here. And then we're just going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, and then the other direction, up 1 to the left. Like that. And we have no line underneath this greater than sign, so it's just going to be a dashed line like this. So don't connect the line so you can see a little better. Okay, let's just graph the other one first, and then we'll do the shading next for both of them. So then the next one is y is less than or equal to 5. So at y is 5, the height is 5, and that's going to be straight across. And it's also going to be a solid line because this line underneath here, it can equal 5. So since we're allowed to equal 5, we're allowed to be on this line that is worth 5. So we have that. So now we need to go back and shade according to the inequality symbol. So back to this first one up here, this is the black graph there. It was greater than, so greater than is going to be above the shape of the graph, or we can plug in a point. If I plug in this point 0, 0, it's not on my absolute value graph at all. I'm going to plug in x is 0 and y is 0. So 0 would be greater than absolute value of 0 plus 3. So we're going to see if this is true. So this is 3 and this is 3 in the end. So 0 greater than 3, no. So I'm not going to shade where this point that I plugged in was. The point I plugged in was 0, 0. So I'm not going to shade here. I'm going to shade on the inside of this black V that I made. So just shading kind of like that so you'll be able to tell better. But also, again, in general, greater than means you're going to shade above it. So that's how you can tell kind of quickly, but if you need to show your work, you should probably do that. So then for the other one, the purple graph, which is just a straight line, it's less than or equal to. The equal to part means that we did the solid line, but the less than means I'm going to shade under it. Or again, if you're not sure, we can plug in a point. Let's plug in the point 0, 0 again. It's not on my purple line. So I'm either going to shade above my line or below the line. This is what we're going to find out. So if I plug in 0 for y, because that's the only variable there is no x, is 0 less than 5? Yes, so I am going to shade where 0, 0 is compared to this line. So that was under the line. So I'm going to shade this way, or like I said, less than usually means underneath. So we can see where it crosses. Let me do that in another color. The area where everything crosses, which is, ew, that's kind of ugly. But you can see that that is the region where all those are solutions in there. So all of those ordered pairs would satisfy both inequalities. So the second part of the question is to find the area of intersection, so the actual space that it takes up. So what's going to be easier to do, we could look at the graph. My graph is not so pretty anymore. Let's find it out with algebra just to be sure. So we want to find where they intersect. To find the area, looks like a triangle. That is half the base times the height. So the base of the triangle is actually going to be this part, and the height is right here. Well, we can figure this out. We can actually figure it out with the graph, but I'll show you algebraically too. But this we can count. We know it's at y was worth 5 and y was 0 down here, so this distance is worth 5. So that is the height is actually worth 5. We know that. Fix that 5 there. So what we don't know is the base. And then we know the 1/2. Okay, so that's what we're trying to figure out. So if I look at my graph, I can either see, okay, there's a point at positive 2, and then a point at, let's see, negative 1, 2, 3, 4, 5, 6, 7, 8 is where they cross. I'm finding the intersection points. So positive 2 to negative 8, that's a distance of 10 right there. Okay, I'm going to put that here. That's 10 long. Or if you don't know, if your graph isn't very good, you can just find the intersection of these two inequalities and just set them equal to each other. So 5 equals absolute value of x plus 3. And to solve that, remember you write two different equations. This could equal positive 5 or negative 5. Both of those things could happen. So I'm going to subtract 3 and I'll get a 2. Subtract 3, and again, you get the same numbers that we had before, but if your graph isn't very nice, you can see, and the distance between these was 10. So that's where we're getting this 10 here. So we just need to calculate the area. So half of 10 would be 5, and then that times 5 is 25. So my area is going to be 25 square units, whatever units we're in. So that's the area of them. So you need to calculate that as well as drawing the graph of the inequalities.